Here we go. Back. Copper calculator and oxidative stress. Take two. Uh, so I'm starting with this study, right? Like we said, because a lot of what happens in a lot of the symptoms that happen in fibromyalgia mimic a lot of the symptoms that a lot of our clients have. So, and oxidative stress, as you'll see, is what the copper zinc calculator helps us figure out. So, in this study, they took fibromyalgia as a form of non-articular rheumatism characterized by chronic widespread musculoskeletal aching. Um, and then some works have investigated the possible role of oxidative stress in the pathophysiology, but none have analyzed a significant number of markers in the same patients. So they're doing a study of the oxidative versus antioxidative status in these patients and versus healthy controls. So what they did was they took 45 female patients and 25 age-matched controls, and they investigated that oxidative lipid protein peroxidation and oxidative DNA damage and the antioxidative status, the total antioxidant capacity, which they use the abbreviation TAC, and antioxidant enzyme activities and compounds. The functional capacity and musculoskeletal pain were assessed by their questionnaires, and they have a visual scale. And then these statuses were evaluated. So what they found was there was a significant increase in oxidative DNA damage, and protein carbonyl content was found in the FM patients versus controls, as well as antioxidant compounds such as copper and ceruloplasmin. So patients had diminished levels of TAC, total antioxidant capacity, and zinc. And the enzyme activities of superoxide dismutase, which is SOD, glutathione, peroxidase, and catalase were lower in those patients. Significant correlations were observed in patients between their DNA damage and um, zinc and those other two parameters that they used. So basically, what they found was there was high oxidative stress. So there was that imbalance, right, between oxidants and antioxidants. The lower antioxidant enzyme activities may lead to oxidative stress through the oxidation of DNA and proteins, which may affect the health status of these patients. So this is all of the symptoms that people with fibromyalgia complain about. And these are all things that when we look at these things, we go, could be oxidative stress, right? Especially when we're looking at high ferritin levels and pain and all the, the free copper that we know is bouncing around in some of these people, right? Um, I guess it's not surprising to us, right, that oxidative stress could be behind a lot going on in fibromyalgia and a lot of things that are going on in our clients too, even if they don't carry the same label, right? So this is the copper calculator, and you guys will be getting, I showed on the um, the page where all our copper videos, there's a link, there's a button for the copper calculator, so you guys can click on that and then save it, bookmark it, so you have it. But you can always go back and log into the membership and grab it if you need it. Um, but these are the ratios and relative NCC score, which is that NCC score. I've got research papers and stuff attached here. Is that oxidative stress score. So when you're putting numbers in here, right, zinc and copper need to be converted to UGs per DL. Sometimes you'll find it in U moles instead, but you'll need to convert it so it's in this form. And you can just Google a conversion for that if you need it. And then ceruloplasmin usually comes in Mg, sorry, magnesium. This is where my brain is, right? Um, milligrams per the deciliter, one of those deciliter, I think. So this line these are expanded. You can click on these in the calculator and it will show you the equations. Normally it just says corrected for CP and then it shows the ratio and then it says copper bound, copper unbound, and the NCC score. All these equals are hidden. But this is just 27 times 1,000 to make it in UG per DL also. The ratio is just this R3 divided by R2. So this is the ideal zero point 0.7 to 1.0. Anything over 1.15 then is considered high, and that's there. And then copper bound with ceruloplasmin. This is for this level of ceruloplasmin, 27, right? So you take that number, actually take the corrected number, right? So for 27 mgs per DL of ceruloplasmin, you correct it, you times it or divide it, by 0.003, and then you get how much copper this amount of ceruloplasmin can bind. And then you just do the math here. So the unbound copper is just going to be the total copper minus the copper that's able to be bound, which gives you the amount of unbound copper, which should be between 5 and 15 in a body that has a balanced oxidative antioxidative status. But in our person here, they're not. It's 19. So an ideal perfect level here for copper bound, right, is 95%. That's what we talked about in the last week sometime, one of the slides. We went over that, right? So in this person, a perfect amount of bound copper would be 95. And you can always play around on the calculator to figure out like what would that perfect number of ceruloplasmin be for this person if this is supposed to be, you know, 95, this number right here. Any questions so far? Or if you had a question last time and you know you asked it? Nope, everybody's
I
good?
have a question. I have a question because
Sure, sure,
I've
go.
never, I mean, I ask often for zinc and copper, always actually, but so ceruloplasmin, you just ask for ceruloplasmin.
Yes. Yeah, it's three separate markers.
Okay. I've never asked for it, but I don't know how it is in Europe, if it's something that they would give you.
I
For
mean, it
example,
should, because the copper doesn't really mean anything. I mean, you can get like this ratio, but you cannot know what is bound versus not bound without this number. So it's
yeah,
so
okay.
important to know what the ceruloplasmin is.
Mm, okay, okay,
And
yeah.
after today, when we talk about it, you'll be able to give reasons for why, that should be. Now, can you order labs for the most part without asking a physician?
Well, with my Greek clients, because it's not that regulated in Greece. In
Mhm.
Greece, everybody can. I order my own labs, my kids' labs. Like everybody orders labs. But for example, when I ask for free T3, already some labs go, "Oh, we don't do that. You don't need that." So that's why
Yeah,
I will start doing it because I see the tremendous value of it. But I just want
right.
to ask you, ask for ceruloplasmin.
Ask for ceruloplasmin. Yeah.
Okay.
Yeah. It's like when we get the iron panels, but we don't have a ferritin number.
Yeah.
You're
Mm.
like, now you can guess kind of sorta based on by that TIBC, right? Because TIBC is going to track more closely with what the body thinks about ferritin, but you don't know for sure if it's acting as an acute phase reactant or not.
Yeah. 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 Yeah.
So
Thank you.
you really need the number. So the relationship between serum copper, ceruloplasmin, and non-ceruloplasmin bound copper in routine clinical practice, there's a link in the membership for this paper, and it talks about why you want to use these and this whole copper calculator, right, is explained by this research paper. So if you want to dive deeper into using it, and do a little bit more research, that's what you're going to want to look at. So pyroluria is a condition that um, that we're going to go over also. So cryptopyrroles form to get rid of waste through the kidneys and use glutathione to conjugate pyrroles through the kidneys or the bile. If you have no or low glutathione, pyrroles will then pull zinc and B6 out with them. So during the synthesis of hemoglobin in the body, waste products called cryptopyrroles are generated. Cryptopyrroles are normally excreted uneventfully, and in those with pyroluria, cryptopyrroles bind strongly to zinc, B6, and omega 6. This especially occurs when the individual encounters any sort of bodily stress, whether it be an illness, overexertion, or mental emotional stress. So it usually isn't something um, that exists all the time, right? It's something that may pop up for people and they won't even know, right, that this is kind of what's behind it. Um, the cryptopyrroles are then excreted in urine, taking these three important nutrients with them, which is the problem, right? So when these nutrients get depleted, what ends up happening on the other side of that, right? What happens? How many clients do we say, oh my gosh, this client is low in zinc and B6? All the time, right? We look at the RBC numbers and we look at an elk phos and oh my gosh, zinc and B6. Um, so these nutrients are critical for the functioning of your entire body, your mind, your digestive system, your immune system, cognitive function, and um, emotions. There's a link there. And I believe I've got a photo of that here. So people with this disorder have copper toxicity because they lack the zinc. According to the study, an imbalance in the copper zinc metabolism in relationship to metallothionein is related to inflammation. And we're going to go into metallothionein too. So copper is not only attracted to inflammation, but it makes it much worse, especially in a free copper state, right? Because in order for copper in the body to be safe and usable, it needs to be bound. Um, It's just like iron, right? It's a metal, it needs to be bound, unlike hormones, right? Which when they're bound, they're unusable. These are opposite that. All right. So you need to flip your brain if you're thinking bound is bad. Because in this case, it's not. The analogy I use in my head is it's like little tiny metal BBs in your body just kind of bouncing all over the place, crazy, causing damage wherever they hit and bounce off of. Um, So the role of metallothionein in copper and zinc metabolism, there's a special reference to inflammatory conditions. And here's the link. There's an increasing body of evidence which suggests that in mammals, copper and zinc metabolism is subject to hormonal regulation. The specific hormones involved include those that control key pathways of intermediary metabolism, so glucocorticoids, glucagon, insulin, and catecholamines. Furthermore, hormonal factors associated with the host defense system, such as interleukins, have similar regulatory effects. A significant factor in the regulation of these metabolic effects is directly related to the control of metallothionein gene expression. In this brief review, we describe the aspects of the metabolism of both trace elements as related to metallothionein as a functional entity and how this is influenced by inflammatory conditions. A lot of words, right? So anytime you have copper toxicity, you're going to have a lot of symptoms that come up on the other side of that. And I know I've shared the copper toxic website before, but there's a lot of information on that website. So you can head over there and look it up. But these are some of the things. So headaches, migraines, fatigue, insomnia, depression, bipolar, skin rashes, spaciness, detachment, learning disorders, PMS, memory loss, hair loss, especially among women, osteoporosis and addiction, and it also leads to the rise of estrogen, which in large amounts is a potent carcinogen and can cause cancer. So copper is super important and it's not on a standard lab panel. It's not in the radar of most health professionals. Um, so Jen had a obsession with copper for good reason because it just does so much in the body. Um, and this whole copper toxicity where, if you don't have good ceruloplasmin levels and copper is there but not bound, it does become toxic. And at the same time, while you have all this copper in the body, your body's also acting and reacting to a deficiency of copper. So, this whole thing when it says bipolar disorder, it really is this confusion in the body of having the copper there, but not being able to access it really causes this confusion. Some with high copper dislike protein. This was so fascinating to me. So people that have this copper toxicity become obligatory vegetarians and crave high carb diets. This is because too much copper impairs liver function, which is necessary to break down protein. So they're no longer able to digest meat very well. Protein feels heavy and causes them other symptoms, although these people are exactly the people that should be eating protein because red meat is the best source for zinc, which lowers the levels of copper and makes the digestive enzymes they need to break down the protein. So it becomes this vicious cycle. In fact, becoming vegetarian actually makes things worse because the vegetarian proteins are high in copper, such as nuts, beans, seeds, and grains. Once zinc is introduced, the taste for meat can come back, and as will the ability to digest it. So if you have clients that aren't vegan or vegetarian because of this moral, whatever reason, and they're just doing it because meat doesn't feel good anymore, this might be at the at the root of that. So in this case, copper foods that you want to avoid, the top four copper containing foods are almond, shellfish, avocados, and kale. And I shared that, on my website, I have that, kale doesn't fix it, eating kale isn't the solution to all your problems because so many people think, oh, we'll just eat some kale and change my diet. And, that used to be all the rage, but um, it's not. And likewise, a lot of people that aren't strict vegetarians will then go and eat a lot of they'll go pescatarian and have a lot of shellfish, and then this is the same thing that happens. So, metallothioneins, the forgotten antioxidants. So, metallothioneins are 23 cysteine-rich proteins. They're the natural way the body moves metals. And when glutathione is oxidized, the toxic metals are transferred over to metallothionein for removal and excretion. And these metallothioneins are zinc dependent. And there's four types. MT1 and MT2 are found throughout the body. MT3 is expressed in the brain, and MT4 is concentrated in epithelial tissues, esophagus, GI tract, upper stomach, and skin. So we need to support the MTs in order to lower that NCC score. So anytime you see that oxidative stress score on the copper calculator, you want to be thinking, how do I support metallothionein? So in fibromyalgia, going back to the beginning, right? MTs may not work correctly because glutathione is low, zinc is low, the body's lacking B6, and it also needs a metal, molybdenum, to function. And it sounds like a lot of the same things in pyroluria, right? So these are all the symptoms in pyroluria. So I could read through a lot of them, but how many of these are just the regular symptoms that most of our clients have? You know, constipation, all the difficulty recalling events and remembering things and remembering dreams. How many of your clients have learning disabilities, dyslexia, fatigue, right? They say that they have mood problems and emotionally they feel on edge. Food sensitivities, frequent infections, hallucinations, hyperactivity, hypersensitivity to noise, hypoglycemia, that inability to think clearly, nausea, mood swings, migraines, nervousness, right? I mean, like all this stuff, guys, right? So much of it can be tied back to this whole copper toxicity, copper imbalance, lack of B6, lack of zinc. So glutathione reduced glutathione conjugates the pyrroles and removes toxins and metals from the body naturally without removing nutrients. But B6 and zinc deficiency prevents the reduction of the oxidized form of glutathione to glutathione. So this is the oxidized form. And this is, in this metallothionein, when you're making metallothionein, you've got the MT thiols, the thionine, which needs zinc to go into zinc metallothionein. And then without the glutathione, you're losing the zinc. You end up, this gets degraded. It's reduced here again, and it just gets recycled. It's oxidized and reduced, and you need zinc, and there's B6 in this process too. So without both of them, you're degrading these, and you're not making them and feeding the whole cycle. They get lost.
Joe,
Yep.
before you go any further, I want to ask you,
Yep.
um, I've got, before you started talking about too much copper affects the liver and then they don't want to eat protein anymore.
Hmm.
Um, Above that, I've got two sentences I wrote that you said, and one is I need zinc to tell me about copper, and I need ceruloplasmin to tell me about copper, and I've got those circled. Is that pertaining to the copper calculator, or did you say that for some other reason?
I think it was pertaining to the calculator.
Okay, thank
Um,
you.
right? I mean, because without let's zip back, right? Without zinc, you can't tell whether you've got a good ratio. And you need to know that you've got enough zinc and enough copper total in the body, right? Make sure that zinc and copper are within adequate range and balanced with each other. That's the first question you have to ask yourself. Does this body have enough zinc and have enough copper, and is it in the correct balance? And that's usually where we stop, right? We get zinc and copper levels and we go, "Yay, 1.1. This person's great," right? This is a great copper ratio. It's not too high, right? It's still 1.1. It's not 1.2. It's not 1.75. It's a little high, but, not terrible. But without the ceruloplasmin, you have no idea how much of that copper is bound. So in this person, the amount of available usable copper that they have is 81. It's not 100. That's not available to them. So then put that in the ratio, right? Think about now 81 to 90. Is that a good ratio? But I mean, right here, it's telling you it's not. That ratio is going to cause oxidative stress because you've got 19 units of copper bouncing around, causing damage in the body. And I've seen this up in 30, 32, 40. I mean, this can get pretty high for people if they're really out of whack. Does that make sense now?
Mhm. Thank you. Yeah. I thought, why do I have this written down here? So I thought I'd ask. Thanks.
Yeah, you need all three. It's like getting a TSH and nothing else. Or how many times do we get a blood count, but there's no differential? Or we get a basic metabolic panel, you know? You're just like, why? Why do I not have all the numbers? So, all right, let me see where we were. Okay, so supplements to consider when there's copper toxicity, and this is happening in your metallothioneins, right? Your NCC score is really, really bad. Zinc, you can, add zinc in up to 50 milligrams a day. Obviously, we don't want to add zinc for too long, but that could be a thing. Vitamin B6, you want to make sure that in the absence of, right? While things are out of whack and they're losing zinc and losing B6 because of this, the cryptopyrroles and pyroluria, you need to be able to give them some that they can use. Molybdenum is the other one. So up to 100 micrograms a day. And then some form of stable, reduced, absorbable glutathione. And that's where you have written down a couple of the ones that I recommended, right? Um, Thorn has the one S something glutathione. Pure Encapsulations has one. Um, Quicksilver has the liposomal one. And I still didn't look up that doctor, so I'll have to do that for you. Um, I have his face, so so you might be able to use precursors such as NAC also in here. I've often recommended clients look up glutathione foods and add that in there. And you want to avoid those four foods that are high in copper, right? No need to add more fuel to the fire if the body doesn't have what it needs to bind up that copper, right? Just throw more BBs in there to cause more damage. Not a good idea. Um, so I came across after this while I was doing some other, you know, looking around for iron and copper and zinc. Um, this It was actually a Facebook group that I'm in. It says iron, copper, and zinc aren't just nutrients to balance, they are circadian regulators. They shift based on light, which I found incredibly interesting. Mitochondrial demand and their redox state. If you get the timing wrong, metabolism breaks down. So, copper obviously drives mitochondrial energy, right? Because in the electron transport chain, how many of you guys have seen the cell core chart? For if you're in my kit group, you've seen it. I can share that with you guys because it is cell core has a Krebs cycle um, chart, and it's beautiful because it's just breaks it down very simply what is happening in the mitochondria. But without copper um, and zinc regulation, you end up with increased reactive oxygen species. Um, and you need copper to get that electron transport chain at the end to work. So zinc supports melatonin, but melatonin suppresses iron at night to prevent oxidative stress. Iron delivers oxygen, but in chronic inflammation, iron gets locked away. And we've talked about this, right? That anemia of chronic disease, not because you lack it, but because your body is refusing to use it. And if you're in that, anemia of chronic disease where, ferritin is an APR and you're locking away iron, um, you're going to end up in all sorts of trouble. So this is the gentleman that posted this. But these are some of the articles that he cited. There's this one, and I'm going to I have not added these to the membership yet. I just put them on the slides right before we started, and I will move them to that huge list of um, resources that we have, but metals and circadian rhythm, and then metal ion homeostasis with the emphasis on zinc and copper, and the crucial link to explain non-classical antioxidant properties of vitamin D and melatonin. And how these are all interconnected is really kind of fascinating. And then this was the other one, the intersection of iron and copper metabolism in the mammalian intestine and liver. And I know we've talked about some of this, and I had some other different diagrams, but this diagram basically talks about how ceruloplasmin works. In the red is the bloodstream, the green lines are the movement of copper, and then the blue line is iron. And it basically talks about when you take in the iron and the copper in food and supplements, basically how it gets moved around the body and how they're interconnected. Um, because you can't remember how we've said you need copper to be able to absorb iron. Um, and this diagram basically in this article talks about all the different places where that happens. And then this is inside the enterocyte, which is on the next slide. And then every time there's a star, this is where they're working together. iron and copper are working together in these different places. In hemoglobin synthesis, in the brain, in the placenta, in the plasma, here in the macrophages, they're all at all these places where they're both working together. Iron and copper metabolism, highlighting points of intersection between these two essential trace minerals. And this just basically explains the slide ahead of it. I'm not going to sit and we don't have to sit and go through it. But it talks about, what the yellow stars mean, what the green lines mean. So take some time, guys, to really understand what this interplay is and why it's so important for you guys to understand how copper and iron and zinc all work together. Um, so it talks about all the different ways. Hepcidin may be stabilized by copper, exemplifying another point of iron-copper intersection. Iron is lost from the body. Predominantly by skin cells and enterocytes and by blood loss, since no active regulatory excretory system for iron has evolved in humans. So that's the only place where you're going to lose it is if you're actively bleeding or losing, cells are being broken down. And then this is a close-up of what's going on in the enterocyte. And I know we have a simplified version of this, I think, for just iron, but I think it's really important to know um, where iron and copper work together here too. Um, so read through it, and it's there for you if you want to, take that deep dive. So this is the synopsis of what Alan, I can't pronounce his last name without actually having it on the screen. So iron, copper, and zinc are not just trace nutrient metals that follow circadian rhythm. Iron, copper, and zinc are transition metals, meaning they don't just sit there as levels in your blood. They move electrons. Copper and iron are more transitional than zinc. They shift between oxidation states. They change form based on demand. They don't just exist in the body. They are used, cycled, and regulated by time, light, and metabolic state. These metals interact, compete, and cooperate in a loop, and that loop is driven by circadian timing. In the morning, iron rises with the light. Sunlight lowers hepcidin, making iron more available. Not because more iron is good, but because more oxygen is needed when the body is active. Copper activates oxygen use. It completes the final step in mitochondria, turning oxygen into energy. That's where I was telling you about the electron transport chain and how copper is needed at the end. Copper donates the electron through the electron transport chain in mitochondria to generate ATP. But energy isn't free. Reactive oxygen species rise as ATP production climbs, right? Every factory has waste, right? So as your body's making energy, it's making waste, reactive oxygen species. So at night, zinc steps in. It supports melatonin. It signals the shift from burning to repair. Mitochondria slow down, ATP demand drops, and all those reactive oxygen species that your body made during the day are neutralized. Melatonin then suppresses the iron, not because iron is bad, because iron plus oxygen at the wrong time creates damage. Copper is stored, zinc rises, and repair happens, and that whole cycle then repeats. How awesome is that?
That is fascinating.
Yeah, isn't it? So what happens when the cycle breaks? If iron is high but copper is low, all that oxygen sits unused, becoming toxic. Energy slows, fatigue creeps in. If copper is high but zinc is low, ATP stays high, but so does the stress, and the system runs too hot. Um, How many times as women, right, our female clients, and I mean, even my husband, I tell him all the time, I'm like, you are a furnace sitting next to me. What is your problem? And I'm thinking maybe his copper is high and his zinc is low and his system's running too hot, right? Get away from me. Um, but how many, of our women wake up hot flashes and things, right? If zinc is high at the wrong time, copper can't do its job. So the mitochondria stay sluggish. Circadian rhythm is the regulator. Iron follows light, copper follows metabolic demand, and zinc follows darkness. This isn't balance, it's a rhythm, it's light, and it's alignment. So that's it.
Joe,
So, Joe, can I? Oh, sorry.
oh, I'm sorry.
No, go
I
ahead.
wanted to ask I wanted to ask a quick question about
Yeah.
the top line that said
Oh, you want to go
something
back to
copper,
the
something zinc.
presentation? Yeah, hang on.
Well, just the part that says then oxygen goes unused and becomes toxic. Is that saying
Reactive
a high
oxygen
level of,
species.
say that again?
Reactive oxygen species.
Okay,
ROS.
interesting. Because
Right?
the only time I remember oxygen being toxic is like in preemies when they
Well,
high
it's
oxygen.
oxidation, right?
Right.
Oxidative damage. It's all oxygen.
That is fascinating because I always think oxygen, oxidative, yeah, I think negative. Oxygen, I think positive. So this put just a new thought in my head. Thank you.
What happens when iron rusts? It oxidizes.
Yep.
Copper tarnishes, right?
So unused oxygen causes oxidative stress.
Mm-hmm.
Fascinating. Thank you. Thank you.